This is Maya. Let's get into it. Imagine your team deployed an enterprise AI workflow 3 months ago. You ran extensive evaluations, dialed in your system prompts, and achieved a 92% task completion rate across production workflows. Today, without a single engineer on your team pushing new code, that same system is operating at 71% accuracy. Your infrastructure dashboards in Datadog are glowing green. Uptime is 100%. API latencies are sitting under 200 milliseconds. But your support queue is suddenly filling up with customer complaints about corrupted records and nonsensical answers. This is the most dangerous failure mode in production software today: silent prompt and schema drift. In traditional backend engineering, breaking changes are loud. If an upstream API renames a JSON key or alters a parameter type, your deserialization layer throws a runtime exception. The error gets logged, and your on-call engineer fixes the contract. But probabilistic LLMs do not throw exceptions when a data contract changes. They improvise. If an internal microservice tweaks a field name, or if a partner API returns an unhandled nested object, a stateless agent loop reads the raw payload, assumes it can infer the missing context, and forces an execution anyway. It takes a guess, feeds that degraded context into downstream tool calls, and writes corrupted data straight into your core databases. The second driver of this breakdown is foundational model weight drift. Foundational model providers are constantly pushing fine-tuning optimizations, safety realignment passes, and inference routing adjustments under the hood without bumping version numbers. A prompt template that produced crisp, deterministic JSON formatting in January starts drifting into conversational ambiguity by April. You cannot solve silent drift by manually reviewing logs once a week. And you definitely cannot solve it by waiting for end users to report bugs. To run autonomous agents in enterprise operations, governance must sit at the execution gateway. Step 1. Real-time trace sampling. You need continuous, automated statistical evaluation running across live production payloads, comparing reasoning outputs against baseline distributions to detect semantic degradation the moment it begins. Step 2. Gateway-level schema enforcement. Intercept all tool calls and API responses before they hit model context. If an external schema mutates, catch the mismatch at the proxy layer before an agent attempts to hallucinate a fallback. Step 3. Automated rollback and circuit breakers. When drift is detected, route execution to deterministic fallback paths rather than allowing degraded models to guess on production data. This is why we built Claire by the algorithm. Claire acts as an enterprise control tower, monitoring live multi-agent workflows, detecting drift in real time, and keeping your digital labor deterministic, compliant, and rock solid. Stop waiting for production quality to collapse before you govern your systems. If you are scaling multi-agent architecture and need zero leakage execution governance, check out how we build at letsaskclaire.com. I'm Maya. Thanks for listening. See you next time.